Hello everyone and welcome back to my channel. In today's video, I'll guide you through setting up an interactive foliage system in Unreal Engine 5. With this system, you can chop down trees, collect wood, and each tree has health, so you need to chop multiple times before it falls. We'll cover everything you need, including setting up a custom foliage asset, using the foliage tool, basic particle system, adding a user interface, and more cool features. I've packed it with helpful information, so I hope you stick around. If you have any tips or feedback, please share them in the comments. I'd really appreciate it. If you find this tutorial helpful, please give it a thumbs up and subscribe for more videos. Now for this tutorial, I'm using the third-person template, so make sure to create a new project using the same template. Also, don't forget to download the 3D assets that I'll be using in this tutorial, which you can download in the description below the video. So first of all, let's create a new folder by right-clicking in the content browser and clicking New Folder and rename it something like Foliage. Now double-click to open it and let's create another folder called Assets. And this is the folder where I'm going to import my 3D assets in. So open the File Explorer, select your FBX models and drag and drop it into the content browser and click on the Import All button. Now I'm also going to import the alpha mask image. And now we're going to change the leaves material. So double click to open the material. And since I'm going for a low poly, flat, dull look, I'm going to change the roughness value. And we can do this by using a constant. And we can add the constant by right-clicking in the node graph and search for constants. But we can also hold down 1 on the keyboard and left-click in the material graph to add a quick constant node. Now I'm going to change the value from 0 to 1 and connect it into the roughness. Now I'm going to add the alpha image. And I'm going to connect the RGB output into the opacity mask input, which is now grayed out. But to change this, simply click on the leaves or the material node and in the details panel, search for blend mode and change the opaque to masked. And also check the two-sided checkbox to make the material visible from both sides. Now let's add some animations to make the wind blow through the leaves. And to do this, we're going to add a simple grass wind node. So right-click in the material graph, search for simple grass wind and add it. Now connect the results into the world position offset from the material nodes and add 4 more constants. Now connect the constants into the simple grass wind inputs and change the values to something like 0.2, 1, 0.3, and 1. Now hit apply and hit save and also change the roughness value in the other material. So add a constant, change the value to 1 and add it into the roughness and again hit apply and save. Alright, now let's change the collisions of the tree models. So let's open up the first one. And here in the upper bar, under the collision tab, click on Remove Collision and add a new capsule simplified collision. Now, disable the grid snap for scaling and click on the Scale tool and scale the capsule until it matches the tree stem, like so. And in the details panel, search for collision and make sure that it's set to block all in the collision presets. Now hit save and do the same thing for the other model. So again, remove the collision and add a new capsule simplified collision and scale it down until it matches the stem. And to work more precise, make sure to turn off the grid snap. And again, make sure that collision is set to block all. Perfect. Now hit save, and that's that. All right, now our models are almost ready to be used as foliage actors, but first we need to create a static mesh foliage. And to do this, right-click in the content browser and search for static mesh foliage under Foliage. And rename it something like F_tree. All right, so now open up this static mesh foliage by double-clicking it. And here under mesh, we have to select our full tree mesh. So the low poly tree full. And now here, below this, you'll see the component class. And by default, this is set to foliage instant static mesh component. But to create interactions with the trees, we'll need to create our own component class blueprint. So to do this, let's go back to the content browser. Right-click in the folder and select Blueprint class. Now, under all classes, search for Foliage Instance Static Mesh Component, this one. And click it and hit select and rename it something like BP_interactive_tree. And now, in our static mesh foliage, we're going to change the component class to our new created BP interactive tree. So select that one and make sure that the collisions are set to block all instead of no collision. Now hit save. And now, before we dive into the interactive foliage thing, let's test if it will work in the foliage mode. So here in the upper bar where it says selection mode, click on the drop-down menu and go to the foliage mode. And here where it says drop foliage here, drag the static mesh foliage and drag it down here. Now click on it to select it. And here we can change some settings. For instance, I like to change the random pitch angle to make it look more natural. And I'm going to change the density to a more lower number. And now we can paint down the trees in our level. So now if we play, you can see that we have added trees to our level. And we can bump into them. Nothing special for now. Now, let's get to the fun part, making the trees interactive. First, we'll create some logic inside the third-person blueprint to check if our character can interact with a tree. If the character can interact, it will communicate with any tree within reach. So first of all, let's go to the third-person map. And here, go to Blueprints and open up the third-person blueprint. And for the logic that we're going to create, we could use a line trace. But since line traces are very precise and I want to simulate the area an X would swing through, we'll use a collision sphere instead. So into the Components tab, add a sphere collision. Call it something like interaction sphere. And in the viewport, drag this sphere in front of the player and change the sphere radius in the details panel to something like 80. Now scroll down in the details panel to add a on component begin overlap and add a on component end overlap node. Now in the event graph, we'll use these events to set a boolean, and this boolean will determine whether we can interact with something when we click the left mouse button, which will be our main interaction key, in this case to interact with the trees. So to do this, we're going to add a boolean. So here in the variables tab, add a new variable and call it something like can interact ? Now drag this newly created boolean into the event graph and click on set get interact. Now copy and paste it and connect the boolean sets to both the onComponent begin overlap and the onComponent end overlap. And we want to set the boolean to true when the onComponent begin overlap fires. So the first one has to be checked to true. Next, create a left mouse button event. So search for left mouse button. And from pressed, drag out a branch. And now we want the condition to be the boolean can interact. So get that boolean, drag it in here, get can interact, and drag it into the branch condition. Now we need to create a way for the third-person blueprint to communicate with the Foliage blueprint that we've made earlier. We'll do this using an interface. And interfaces are a simple way to communicate between blueprints. And to create one, just right-click in the content browser and search for Blueprint Interface. Now rename it something like Chop Tree Interface and double-click to open it. Now by default, there's a function and we're just going to change the name of it to something like chop. And we're going to add two inputs, and you can do this in the details panel. So 1 and 2. The first one is going to be called damage, and it's the type of a float. And the second one is going to be called index, and this is going to be the type of a integer. Now hit compile and hit save. And we can close this for now. Now to make this work, we need to add the interface to the blueprint interactive tree. So open up the blueprint by double clicking. Now here in the top bar, go to the class settings. And in the details panel under interfaces and implemented interfaces, click on the drop down that says add and search for our newly created chop tree interface. And now as you can see, there's a chop under interface, and by double clicking it we can add it to the node graph. Alright, now let's go back to our third person blueprint to test this out. So to trigger an interface event, we need to check if the object we're interacting with has an interface assigned to it. And you can do this by dragging out a So drag out a does implement interface node from the other component outputs. Now select the interface that we've created. And this return value, we're gonna stick this into a branch. So now if we left click and there's an object to interact with that has the chop tree interface assigned to it, it will trigger the chop event in the interactive tree blueprint. So from this true output, let's search for our chop tree interface and click it. And now what we need to do is we have to connect the other component outputs to the target of the chop. And we have to do the same for the other body index and the index inputs of the chop message. Now let's test this out. So first of all, let's hit compile and hit save. And let's go back to the blueprint interactive tree. And from here, we're gonna go for a print string. And we're gonna say something like chop. And I'm also going to add another print string to display the index that we're interacting with. Now hit compile and hit save, and let's go back to the third person map and let's check it out. So if we're in front of a tree and we hit the left mouse button, you can see it says 7 chop, and at another tree it says 2 chop, and here it says 4 chop, and if we're not in front of a tree, it doesn't do anything at all. Now we're going to create a structure. A structure is a collection of variables that allows you to organize a group of related data together. We'll use this structure to hold variables that will be assigned to each tree. This will help us manage and manipulate the properties of each tree more efficiently. Now, to create a structure, just right-click in the content browser, search for structure, and then rename it to something like s_foliage info. Now, double click to open it. And here we just have to add 2 variables. Now, the first one we're going to call damage amount. And this will be a float. A float. And the second one is going to be a boolean with the name of isTreeCut ? And like I said, this is going to be a boolean. Now hit save, and we can close this for now. So next we'll use the structure in our interactive foliage blueprint. And inside the blueprint, we'll use the onEventBeginPlay node to get all the foliage instances. Create an array with the 3 instances and assign the damage amount and isTreeCut variables from the structure. So let's do it. All right, now first we have to go to the interactive tree blueprint, and from the event_begin_play, we are looking for the for loop node. And next, we need a getInstanceCount node. The getInstanceCount here. And we're gonna put the return value into the last index input. And now we have to create a variable. And this variable, we're going to call it something like foliage info. And here in this dropdown, we're going to look for the structure that we've created. So the foliage info, as foliage info, the structure. All right. And now we just have to right-click this icon to turn it into an array. And we're going to drag it into our event graph. Now from the loop body output, search for a set array element node and connect the foliage info in the target array. Now also do the same for the index. And when you right click the item, click on split struct bin. Now this is where you can assign the health of your tree, but the default value works for me, so I'll leave them as they are. But feel free to make changes to them to suit your needs. Also make sure you click size to fit. Alright, now let's start with the real logic to cut down the tree. And first of all, what we're going to do is we're going to remove these nodes for testing our interface. And we're going to drag out the new created array with all the instances into the node graph. So get this. And from here, drag out a get reference. Now plug the index from the event chop into the get reference and split the struct bin to reveal the variables for each index in the foliage info node. Now from the isTreeCut boolean value, we want to drag out a branch and connect it with the event chop. Now what we want to do is we want to add the damage from the event chop and the damage amount together. And we're going to do this by using a add operator. So drag out a line, search for add operator, and connect the damage amount and the damage from the event chop. Now, if the tree is not cut down, we want to store this new value. And we're going to do this by using a set array element node like we did earlier. So from false, we're going to drag out a set array element node. And again, we need to connect the index and we need to connect the foliage info. Like so. And now what we want to do is we want to store the new damage amount value. So split the struct bin and connect the outcome of this sum into the new damage amount node. Now what we want to do is we want to make logic for when the tree is cut down. So what we're going to do is from this sum, we're going to search for a greater or equal node. And when the damage amount is greater or equal than 1, we're going to create a new branch from this. And then we're going to connect the array blah, blah, blah. And if this is true, we're going to go for a set array element again. And we have to connect everything like we did before. So it knows what we're trying to get with. And then we're going to split the struct bin. And we're going to say, yes, the tree is cut. So then if the tree is cut, it won't add any other values anymore. All right. Now let's make the tree fall down. And since we're working with instances and not actors, we have limited options for manipulating the tree. For example, I wanted the tree stump to be visible after cutting down the tree, but I couldn't find a way to replace the instance mesh. I also tried to remove the instance using the remove instance mesh node, but this caused issues. Because when you remove an index, like index 4 in an array of 20 indexes, index number 5 becomes index number 4. and all subsequent indexes shift back by 1. This means the new index 4 retains the values of the old index 4, including the is3 cut boolean being true, preventing further interaction, which is very problematic. However, we can use the update instance transform node to resolve this. By using this node, we can move the tree deep underground, like a trash can for chopped trees. Although I couldn't spawn a tree stump instance at the same location, I came up with a solution. Include the tree stump in the 3D asset of the tree, like a mirror. When the tree is cut, we'll flip the instance 180 degrees to reveal the tree stump, which was initially hidden underground. So that's my little hack for this technique. So to do this, first we need the transform value from the instance. So use the getInstanceTransform node and make sure to drag it out from the index. So getInstanceTransform. Now what we need to do is we're gonna promote this to a variable. And we're gonna call it something like original transform. And drag it here. Voila. And now what we're going to do is we're going to create yet another transform variable called new transform. And we're going to drag it into the event graph. And instead of get, we're going to go for set. Now connect the two. Split both struct pins. And also split the rotation struct pin. Now connect the location and the scale value. Do the same for the roll and the yaw value. Now for the rotation Y or the pitch, we're going to use a subtract operator. Connect it to the new transform rotation Y pitch. And we're going to say 180. So this way it will flip 180 degrees. And now what we need to do is we need to get the update instance transform node. And we're gonna get the result of the new transform into the new instance transform. Make sure you do hit the world space and do the same here. Select world space. And now we need to also connect the index and just adding another reroute pin. And now hit compile, hit save, go to the third person map, and let's test it out. So what it should do is when we hit it a couple of times and the damage amount is greater or equal than 1, it will flip upside down. And it doesn't work somehow. So I think this is because we didn't set the damage amount. So to do this, let's go into the third person blueprint. And in the chop event, we have to set the damage amount to something like 0.25. And then after 4 chops, it will go down. Yes, it works. Perfect. So now what we want to do is we want to create a new actor that contains the upper part of the tree that will fall down. And to do this, just right click in the content browser, go to new blueprints, click on actor, and let's call this upper tree. Now double click to open it and add a new component and search for a static mesh component. Now in the details panel of the static mesh components, look for the upper part of the tree. So search for tree, and in this case, the low poly tree cut. Now we want to enable the physics. So search for physics and click on the simulate physics checkbox. Now another thing I want to do is when the tree is cut down, I want to make the upper part of the tree disappear. So go into the event graph, and from event play, search for a delay node. Now let's say we want to make it disappear after 6 seconds. So change the duration to 6. And from completed, drag out a destroy actor node. Hit compile and hit save. And that's that. Now go back to the interactive tree blueprint. And from here, we're going to search for a spawn actor from class node. And in the class dropdown, search for the upper tree. And I want to give some offset to the spawn transform. So we're going for the original transform variable and get it. And now split the struct bin and split the spawn transform struct bin as well. And I want to have the rotation to be the same as well as the scale, but I want to add some offsets to the location. To do this, we're going to use an add operator. And I want to offset it with a value of, let's say, maybe 25 on the z-axis. And for the collision handling overrides, we're going to say try to adjust location, but always spawn. And let's test this out. So let's walk up to a tree and click a few times, and voila. There is our falling tree, and it disappears after 6 seconds. And now we can do the same for the other trees. This one isn't falling down though. Let's try this one. And also this one is not falling down. And this one is also not falling down. This one is. All right, now we can change this by tweaking maybe the offset. So spawn the upper tree, we can maybe say like 125. This will make it change. Yeah, look, and it's falling down now. Perfect, perfect. All right, now let's create the pickup item. So to do this, right click in the content browser, go to blueprint class and click on actor. Now let's call this something like pp wood pickup. Now open it up. And first of all, what I'm going to do is I'm going to add a sphere component. And then I'm going to add a static mesh. And for the static mesh, I'm going to search for the wood pickup asset. And I'm just going to drag it inside of the sphere. Now, the sphere, I'm going to drag the sphere over the default scene route. And then what I'm going to do is I'm going to change the visibility of it. So search for visible and uncheck that. And I'm going to enable physics. So go to the physics, check the simulate physics, and I'm going to add a constraint to lock the rotation on the X and Y axis. Now, next, I want to give it a rotating movement because I want to make the logs rotate. I think that's nice for a pickup item. So I'm going to search for a rotating movement. And then I'm going to change the rotating value. So I'm going to the rotating component. And then here in the rotation rate, I'm going to change the z-axis to something like 45 degrees. I'm going to hit compile and save. And now if we drag it into our level and we're going to hit play, we can see that we have a rotating pickup item. But right now it doesn't do much. We can't pick it up or anything. So first of all, let's go back to the wood pickup blueprint. And in the event graph, we're going to add an on-component overlap node. So click on the, or add a sphere collision. So search for sphere collision. And add a on-component begin overlap node. Now from here, drag out a branch. And if the branch is true, then we want to destroy the actor. So search for destroy actor. But now we have to set the condition, of course. Now to do this, we're going to get the player character. Get player character. And from the return value, we're going to search for the equal operator. And then we're going to use the other actor output and connect it with the is equal operator. And then this condition is the input for the branch. So let's test that out. Now, if you walk up to the pickup item, it disappears. All right. So now let's create a spawn logic. So let's go back to the interactive tree blueprint. And let's just copy the spawn logic for the upper tree part and drag it out behind it. Now we want the logs to spawn between the stem and the upper part of the tree. So this value of 125, let's change it to something like 65. And then here in the class dropdown, let's search for the wood pickup. All right, now let's test it out. So if you walk up to a tree and we click a few times, then the pickup appears. And if you walk up to it, it disappears. And sometimes when you're too close, it will disappear immediately. So to change this, maybe we can also give it some offset on the y-axis. So let's say 100, hit compile, hit save. Let's test it out. And now it spawns next to the tree. So I think I like that. All right. So now let's create logic for collecting the woods and adding all the values together and displaying it in the viewport of the player. So let's do that. All right, so first of all, let's go to the third-person blueprint. And in here, we're going to create a new variable. And we call this wood amount. And it's going to be the type of a integer. Hit compile and hit save. And now we're going to the wood pickup blueprint. And now I'm just going to drag the destroy actor a little bit further away because we have to place some logic between the branch and the destroy actor. So let's get a cast to third person character. And the object is going to be the other actor. And then from the third person blueprint character, we're going to get the wood amount. Then we're going to use an add operator. And we're going to say something like, well, let's give it, for every tree you cut down, you get 5 points of wood, for example. And then we're going to set the wood amount. Is that possible like this? No, that is not. Set wood amount. All right. Oops, that's the wrong thing. Now connect the lines. And this is going to be the new wood amount. Now let's hit compile and hit save. And now we're going to create some logic to display it on the screen. All right, now to display the amount of wood, we're going to create a new widget. And to do this, just simply right-click in the content browser. And here under user interface, go to widgets blueprint and click on user widget. Now rename it something like w_main widgets and double click to open it. And first of all, we're going to add a canvas. So in this palette section, search for canvas panel and drag it into the graph. Next, we're going to search for a text object. So just add it in there and let's change the content to something like simply wood. And next, I'm just going to copy this and place it next to the wood. And here I'm just going to delete the text content and I'm going to create a binding. Now, what this does is this will get the amount of wood. And in order to do this, we simply drag from the get text a cast to third person character node. And then from the object, we're going to get a get player character. And then from the as third person character, we're going to drag a get wood amount. And then we're going to add the output into the return value input. And this will automatically add a toText node. Now hit compile and save. And now what we need to do to display this widget, when we go to the third person character and we go to the event begin play node, from here we have to drag out a create widget node, like so. And from here we're going to select the main widgets. And then from here we're going to drag out a add to viewport node, like so. And make sure that this return value is connected. And then hit compile and hit save. And now if we play, you can see it displays wood 0. And if we walk up to a pickup item, it says wood 5. And if we then chop down a tree, and we automatically collected it, it says wood 10. And now if we walk up to this one, it says wood 15, wood 20, and here wood 25, and so on and so on. So there you have it. Now we can collect the woods and we display the woods. Perfect. All right, now to make things juicy, we will add some sound and particles for the chopping and the collecting of the wood. So first of all, let's create a particle system. So right click in the content browser, click on the Niagra system, then new system from selected emitters, click next, search for the omnidirectional burst, click the plus icon and then click finish. Now rename it something like chop particles and double click to open it. Because here where it says initialize particle, when you click it, we can change the color. And I'm going to change the color to a nice brown color, like the bark of the tree and click OK. Now hit compile and hit save. And now to use this emitter, we're going to the interactive tree blueprint. And here between the first branch and first set array element nodes, we're gonna add the particle system. So to do this, from the false output, search for a spawn system at location node. And then here where it says system template, search for the chop particle. Now for the from the instance transform node, we are going to create a new transform variable. So drag it out here and say promote to variable, and we're going to call this chop particle. And then we just have to place this set node between the false and the spawn system at location nodes, like so. And now we can split the struct bin, and we can say that the rotation is the same, the scale is the same, and again, I want to add some offsets. Now, to create some space, I'm going to drag this out a little, and then from location, I'm just going to search for the add operator, and I'm going to give it an offset of, let's say, 65, and add it into the location. Now hit compile, hit save, and let's test it out by walking up to a tree and click, and voila, we have a particle system until it falls down, and then afterwards we don't have the particle system anymore. So perfect. All right, now we're gonna create 2 more particle systems, and the first one is gonna be a particle system that floats above the pickup item. So to do this, again, we're going to create a new Niagra system. Click next, but this time search for the fountain template. Click on the plus icon and click finish. Now let's call this something like pickup particle. Double click to open it. And the first thing we're going to do is we're going to disable the gravity force. So disable that. And then what we're going to do is we're going to click on the add velocity. And here where it says in cone, we're going to say linear. Now what we're going to do is we're going to the shape location. And here we're going to change the sphere radius to something like 40. And the next thing what we want to do is here where it says initialize particle, we're going to change the size where it says sprite attributes, and then the uniform sprite, we're going to say something like 3 and maximum value of 4. And we're also going to change the lifetime to something like 2.8 and 3. And here in spawn rate, we're going to change the spawn rate to something like 12. So now we just have small particles, not too many. Maybe we can even say 6 instead of 12. Just a very subtle effect. All right, now let's hit compile and hit save. And back in our content browser, we're going to create another Niagra system that's very similar like the chop particles. And this is going to be, again, a omnidirectional burst. And we're going to call this pickup burst. All right, so we have the pickup particle, we have the pickup burst, and the pickup burst is just the same. Maybe we can change the color. So if we're going to the particle spawn, maybe make it yellow or something. Okay. Hit compile and hit save. Now, first of all, we're going to add the fountain particle. So to do this, we go to the wood pickup blueprint. And here, when we go to viewport, we want to add the particles. So in the components tab, add a Niagra system. Niagra particle system components. And by default, it says pickup burst, but we want to grab the pickup particle. So as you can see now, it has floating particles. Hit compile and hit save. And then what we want to do when we go to the event graph, before the actor gets destroyed, we want to add the burst particle. So let's drag out a spawn system at location. And we're going to select the particle burst for the, let's say, burst, pickup burst. And now for the location, we just need the location of the sphere. So get world location. And here it says get world location sphere. We're just going to get that. And we're going to split the struct bin. Or no, we're going to recombine the struct bin. And we're going to connect it to the location. So now let's test it out. So this will, before it gets destroyed, it will spawn the particle system. So we see the particles floating above the pickup item. And when we walk into it, we have this pickup burst. So we have the chop tree particles. Then we have the particles when it poops. Yeah, that's something we need to tweak. But here, as you can see, it has nice particles. Very cool. All right. All right. So now the last part, let's add some sounds. So first of all, let's create a new folder called sounds. Double click to open it. And in here, we're going to add the sounds that we're going to be using. The first one is a sound for collecting and the other one is a sound for chopping. So let's go to the interactive tree blueprint to first of all use the chopping sound. And we're going to place the chopping sound right after the spawn system at location. And for this, we're going to use a play sound at location. And we're going for the wood chop sound. And for the location, we're just going to use the same value as the particle system. So just get the particle system and put it into the location. No, that doesn't work. Then we're just going to get this pin and drag it into the location. All right, let's test it out. All right, that works. And now I also want to have the pickup sounds when we pick it up. So let's go to the wood pickup object. And here, between the spawn system at location and the destroy actor, we're gonna search for the play sound at location node. We are going to get this same location as we used with the particles. And for the sound, we're just gonna get the collect sounds. All right. Now hit compile, hit save, and let's test it out. Now if we walk up to the pickup item, yes, we have a collecting sound. All right. Perfect. All right, now let's tweak some things I don't really like. For instance, let's go to the widget because the number is not aligned with the wood. So in order to do this, let's check the Y position must be the same. So if this is, for example, 72, then we need to make this 72 as well. All right, that's the first thing. Hit compile, hit save. I also think that when we play, most of the times the collectible item spawns inside the area where the player can pick it up. So I want to change that by using a delay in the pickup item before it gets destroyed. Or even not before it gets destroyed, but I want to add a delay before the Niagra system gets spawned. So I'm just going to drag this here. We're just going to change this. Then from here, I'm just going to add a delay node. And I think maybe the duration of half a second, so 0.5 will do. So this way we bump into it and it doesn't disappear. I like that better. All right. Well, and I think that's about it. You can change other things you maybe don't like. For example, if you go into the interactive tree blueprint, you can maybe change the offset values of the spawning upper part of the tree and the pickup item. But yeah, this is the foliage interactive foliage tree chopping tutorial. So again, and that's the best part when you go into the foliage mode and we remove everything and we're just gonna paint the trees. We can create a whole forest using this technique and everything is interactable. So yeah, of course you can expand on this. You can also create a system that handles different types of objects that you can interact with. Maybe you can want to interact with rocks or minerals or like, I don't know, gold and stuff. It must be all doable using this system. So yeah, that's about it. That's the tutorial. So I hope this video has been useful for you. If you have questions, please let me know in the comments and I will try to answer them. I hope this video will motivate you to expand on this system, maybe add other interactable objects like rock, for example. This definitely needs some good animations for the character and of course an axe and some time between each chop, but this is the interactable foliage system. So leave a like if you've enjoyed watching and subscribe to my channel for more videos, and good luck with making your dream games in Unreal Engine.